dear engineers, ladies and gentlemen. Today, actually, Electrical, Electronic and Telecommunication Engineering Sectional Committee of IESL has organized a very insightful webinar on harnessing load forecasting for a sustainable energy future. So we have invited an expert in the field, Dr. Kasun Bandara, forecasting analytics lead, Energy Australia. Actually, related with bringing the speaker, we must extend our thanks to Dr. Charit Jayasekara, representing the Public Lectures and Sessions Subcommittee. Actually, before just going into the webinar, as a background, we must understand that as far as increasing more penetration of renewable intermittents into the grid is concerned, always renewable energy experts highlight mainly three key points. The first one is the distributed energy, or in other words, decentralization, and the end user electrification. And the second point is harmonization. And the third one is digitalization. So in this context, digitalization and automation of this renewable generation and also the demand side is very important. So we need supply side management, at the same time demand side management. Therefore, so today we are going to discuss very timely topic on harnessing load forecasting for sustainable energy future, because this has become sort of national thematic requirement in our country. Therefore, this is very good topic that we all must have some good understanding. Therefore, just to introduce our speaker today, I would like to invite Dr. Charit Jayasekara. Please, Dr. Charit, introduce our speaker today.
Thank you, Dr. Kumar, and hope you are having a wonderful evening, everyone. I would like to express my sincere thanks to Dr. Sandun Konar, the chairman of Public Lecture Subcommittee, and Chair Zara Marsuk for helping us to arrange this one and arranging all the necessary things related to this webinar. So myself, Charit Jayasekara, and it is my pleasure to welcome you all to this exciting and highly relevant webinar on harnessing load forecasting for a sustainable energy future. As an academic and a researcher in the field of computing and information systems, I have always been passionate about intersection of technology and data. Also real-world applications, especially when it comes to solving critical challenges. And today, we are here to discuss one of the most pressing challenges in Sri Lanka energy sector, how we can ensure a stable and efficient power supply while integrating more renewable energy sources like solar power. To shed lights on the topic, we are privileged to have an exceptional expert in the energy forecasting with us today, Dr. Kasun Bandara. If I tell a little bit about himself, his expertise in load forecasting, machine learning, and energy analytics has positioned him as a leading authority in the field. He holds a PhD in computer science from Monash University. Also, he has worked both in research and industry, developing advanced forecasting models for electricity, gas, solar, and energy demand. Currently, he is the load forecasting and analytics lead at Energy Australia, where he plays a critical role in optimizing energy planning and energy market operations. His insights are not just theoretical, but also highly practical, directly impacting energy sustainability trading, and policymaking. Why this is important nowadays? Sri Lanka is undergoing a transformational shift in its energy landscape. With the increasing adoption of solar energy, we must ensure that our grid remains stable and that we must ensure that we can accurately predict energy demand and supply fluctuations. Poor forecasting can lead to power shortages, energy efficiencies, and economic setbacks, while advanced data-driven forecasting can help us optimize energy distribution, reduce cost, and move towards more sustainable future. So today's session, we will deep dive into how Sri Lanka can leverage modern forecasting techniques along with the solar energy more effectively, learning from best practices used in Australia and beyond. So without further ado, it's my absolute honor to welcome our speaker for today, Dr. Kasun Bandara. The meeting is yours.
Thank you very much, Dr. Charit and Dr. Konara for the kind introduction, and sincere gratitude for the IESL Sri Lanka for giving me this opportunity to share the insights of the importance of load forecasting in the current energy market. The accurate demand forecasting is quite essential for the authorities to plan their resources more effectively and also more in advance. So they can plan their resource more effectively and to make sure that there will be a more reliable and a stable power system, right? So the objective of this presentation is to find what are the key driving factors of the energy demand, particularly in the current context with the surgence of solar into the market. There's a direct impact on the energy or the load shape. So we will be assessing the importance of solar and how it's actually impacting the total load. And secondly, I will be discussing about different techniques that are available to demand forecasting and how to improve the demand forecasting accuracy. And the third one, I will be discussing about different procedures that is already available in the Australian energy market to make sure that you have a stable, reliable grid, ensuring that you have a proper frequency between the load and the generation, right? So those are the main topics that I'm planning to cover today. So moving into the outline of the presentation. So since my analytics and all my work on this presentation is based on Australian energy market, I will be first given an overview of the Australian energy market, which would also help you to understand what are the key differences between the Australian energy market and the Sri Lankan energy market. And then I will be discussing about the importance of electricity short-term load forecasting and the techniques available and the best practices available in the industry to improve the load forecasting, and obviously discussing about the key variables that are impacting towards the load. And then I will be talking about the maximum and minimum operational load, which are two important factors and two extreme points that usually need to capture in our load forecasting. And 10 years back, we have not seen much thing about minimum operational load, but we do see it now because of the prevalence of the solar generation. And as a conclusion, as to conclude the presentation, I will be talking about the future of the load forecasting, talking about what would be our energy market in another 10 to 20 years, and what are the challenges that we would probably have to pursue in the load forecasting space. So just to give an overview of the Australian energy market. So the current, like the most fundamental aspect of transportation of from energy generation to the household is same as the other parts of the world, like in Sri Lanka and Australia. But the key distinction lies here is the ownership of the entities relevant to the supply chain, right? So in here, there will be multiple players in the generator market, and also there will be multiple players in the retail market as well. On the distribution line, you do have limited players, but you still have multiple players in the market. So that in that way, the energy market has driving for more competitive market, giving more better competitive prices to the retailers. So that's the main objective of having this more decentralized energy market with different entities in the supply chain. So that would be the main distinction, I would say, with the Sri Lankan energy market, because it's mostly controlled by the CEB. So just to give an overview of the Australian energy market about the NEM. So that's what we call the national electricity market in here. So it's one of the longest interconnected systems in the world. As you know, Australia is a big country. In fact, it's a continent. So to connect all the households together and for the generation power line, it has to be quite long. And it connects 5 states, Queensland, New South Wales, Victoria, South Australia, and Tasmania. And for the people who are looking for Western Australia and Northern Territory, they have another market. That's what we call the WEM, the Western Australia Energy Market. And these two markets are controlled by the Australian Energy Market Regulator. So that's what we call the AEMO. So that's the government body that regulates this market. So there will be multiple participants, as I mentioned. There will be multiple generators, multiple retailers would be in the market, and the transmission and distribution lines are providers as well. So that's what we call the participants in the Australian energy market. So just for the information purposes, people who are interested in finding the energy mix in Australia, so still mostly the coal is the most driving factor for generating energy, mostly around 55%, but the renewable energy has become a quite important factor, moving to the 2050 net zero plan in Australia. So Australia has a national pledge to have their coal generators to be decommissioned in 2038. So that's why in the next coming years, you will see more renewables in the market, but still it's most dominated by the coal powered station. And you will, if you are following the Australian politics closely, you will probably see the nuclear power generation has also come into the talks into the future. So this is the future of the electricity generation in Australia. As you can see, as we move to the 2030s and 50s, more and more renewables are coming into the play, and more non-renewable energy like black coal and brown coal are diminishing, and the other resources like renewable energy are increasingly becoming popular. So that actually poses other challenges for load forecasting that I will be discussing in the next couple of slides. So what I do, so in my team, so I actually work for Energy Australia. So Energy Australia is a gentailer. So that's a generator and a retailer, right? So just to clear out, so I'm not working for the AEMO. It's not the Australian Energy Market Operator. So it's the EA is a generator and a retailer and as a participant in the Australian energy market. So just like for the AEMO, it's important for us to predict our retail energy demand. It's pretty crucial because we need to identify what's exact our retail load. So then we can optimize our generation plans based on the retail load that we have. So we provide short-term, medium-term, and long-term forecasting for different energy sources. Electricity, gas, and solar becomes a main input to the electricity demand forecasting. So for the people who are looking at why gas, so the gas is important because it's one of the main resources for heating. So the Australia is a 4 seasons country, so they have the winter as well. So it's important that you have resources for heating purposes as well. That's why we have gas. So we have an electricity short-term market, and you have a gas short-term market as well in Australia because for the heating purposes. So the objective or the overall goal of our team is to analyze the demand drivers of these sources, and then accurately demand forecasting to the short term, medium term, and long term. So this presentation, I'm mostly talking about the short term view, but I will be touch basing some parts of the medium term as well. So in addition to that, we are providing insights into the government energy scheme obligations and assessing how they are impacting our load as well. So in addition to generating the forecast, we also doing these other analysis and assessments of the impact towards our load because of the government obligations. So moving into the electricity short-term load forecasting. So why do we need that? So for the system as a load, it's quite important so we don't run into blackouts. So you need enough load in the system so the generators can run and fulfill the demand of the customers. So that's on total wise. From a retailer or a gentailer perspective, it's important also, as I mentioned earlier, so the retail load can be identified so we can schedule or optimize our generators more effectively. So in our company, so we have someone called the physical market traders. So they require to plan their energy schedule or generation schedule. The electricity short-term forecast is a major input to that optimization procedure. So that's why we have to provide electricity short-term forecasting. And obviously it supports the spot market bidding activities in the Australian energy market. So I will talk about this, what do you mean by spot market bidding activity and how it operates in the next slide. So usually for the retailer, so the load forecasting requirements is usually range up to 14 days ahead. And forecast is also segment wise, depending on the segment you have. It could be a mass market or it could be a large commercial industries, right? So for example, in Sri Lanka, it would be a apparel industry, right? And we will be providing the forecast at half hourly granularity, right? So it's important that we segment these different customers as well, because the load profile of these customers are quite different. For example, mass market are quite sensitive to temperature related activities, but for the commercial industries, mostly big, operating units that are running 24 hours, they don't have much sensitive to the temperature. So the load profiles are quite different. So important we generate them separately and also track those forecasts separately. So for the AMO perspective, it's important that that you provide the system load forecast. That's for the entire region. But we forecast is for our customer portfolio. But for the AMO, that's for the entire region what they forecast. That would be for an entire region. That would be New South Wales, Victoria, or South Australia. Okay, let's talk about what do you mean by the electricity supply bidding model. So this is the generic physical market framework that you have in Australia for settlements or energy settlements, right? So what we have here is Australian Energy Market Operator, that's the regulator. For each 5 minutes, they provide operational demand forecast. So that's what you see in the vertical line here. So you have 350, sometimes it could be 500, or would be in the evening peak, it would be even 900 megawatts, right? So as the generators or the participants, they actually ask the generator to participate to cover this load. For example, say it's 350. So generator offer bids to meet the demand based on the prices or short running average cost for 1 megawatt, how much the generator cost. So based on that, they bid for the market. So as the regulator side, what it tried to see is to what sort of stack of capacity that needs to be met to complete the 350 megawatts of total load, right? And then what the AEMO does, it sorts all the capacity of the generators based on their prices, and then see in which generator or which price that this load would be met. For example, in the 351, after the base water generator and the Lindell generator would be the price that would be the price would be settling in the market. For example, that would be around $22 there, right? So for example, if the demand is 500, the market would be settled down in for around $30, right? So depending on the demand, that clearance price would be changed, right? So, but the most important factor is the price, like the final price the generator would give for that particular 5 minutes would be the clearance price. So for example, the person with the generator with the base water would get the $22, and also the first generator that bid the yield would also get that $22, right? So that's the usual process on the supply bidding model that is used to settle the market, right? And this process is actually happen every 5 minutes. So every 5 minutes, a demand forecast has to be produced and this market needs to be settled, right? So what are the factors that could affect the prices, right? So obviously, if the demand is pretty high, the demand would be pretty high. The generators that required to settle that demand would be increased, so that eventually the prices would increase as well, right? And the other factor would be, say, if the generator, unplanned event happen, generator shutdowns, that the whole bid stack would move to the left-hand side and the prices would increase as well. So there are different factors that could influence toward the price of each 5 minutes. And the bidding price usually range between -1,000 megawatt per hour and $17,500 megawatt per hour, which is set by the market operator, which is AEMO, right? So usually the high prices, 17,500 usually happens if you have huge, shortage of normal inexpensive generators, and then we had to go into more expensive generators like the gas generators. So the prices would be high in that cases. And also if the demand is quite high, to complete that market settlement, to meet that demand, you need to have more expensive generators in the flex. About the -1,000, so people were probably wondering why you have -1,000 here. So the reason is, in situation where the demand is quite low, say at night, so the coal power generators usually to make sure that are actually running on 24 hours, because it's not good for the coal generators to turn on and turn off intermittently. So usually it takes a lot of time. So the coal generator would take the short run loss over the long-term profit. So otherwise, if they don't bid a more competitive price at that time, they would not be, might have to switch off the generator, right? So for example, say that the 350 is the system demand at that time, all the generators that have been higher than that would be asked to turn off by AEMO. All the ones on the left-hand side only will be operated. So making sure that your generator will also be active 24 hours. So the generators would bid for more lower prices, but that doesn't mean it always settles at -1,000. Even though you bid at -1,000, the market would settle around at $10, right? So you will get the $10 at that time. So about the spot market prices. So as you can see, there can be the price volatility is something that is quite prevalent in this market. So it could go to low prices, and it can even go to a higher prices as well. So this is the histogram of the prices for the state of New South Wales last year. So you can see the prices is usually around 0 to 500, but there are instances that has gone to 17,500, and also situation that has gone to around -$500 as well. So there are a range of outcomes, but usually centers around to 0 to $500. Okay, so moving into the electricity load profile. So this is the usual retail load profile that we have as a usual retailer. So as I mentioned, we segment the demand into mass market and CNI. So for the mass market, just like in Sri Lanka, you will see two different peaks. One peak in the morning, another peak would be in the evening. And naturally, the evening peak is a bit higher than the morning one. And you have the CNI load as well, which is not particularly sensitive to temperature, but it has a more flat profile throughout the day. So that's in the blue color, you see the actuals, and you on the orange color, you see the forecast. So that's would be the difference would be the thing that we need to minimize to provide more accurate forecast. So this is for a 1 day, December 5th, 2024. So this is the retail profile. And if you go to the system demand for the entire state of Victoria, so the blue color is the system demand, very similar to what we saw in the retail demand. You have two peaks, one in the morning, the other one at the night. And the red color, what you see is the spot market price, the one that the bidding price I was referring to previously. So as you can see in the morning, the prices are like in the first peak, it gets high, and then it's a bit stable. And again, at night, the prices would high. That means the higher demand, you need more generators come into the flex. So that means it will be a more expensive price that would be settling. So that's the relationship between the price and demand in the Australian energy market. All right, so working into the electricity short-term forecasting, what are the key inputs and the best practices? So the most important key inputs would be the weather variables, right? So you would have temperature, humidity, wind speed, and another important factor that we take into account is the system demand. So AEMO publishes the 5-minute system demand. So we take that in as a variable as well, because that variable gives more insights into the solar irradiance and behind the meter changes, like quick changes we don't have, we don't have the access to usually in the public terms. So we do use that as an external variable in our short-term model. And usually these half-hourly weather forecast variables are provided by a third-party forecast supplier. And as I mentioned, system demand is often sourced by the Australian energy market operator. And we model the per customer usage because the customer number would change drastically throughout the years. So we normalize our demand using the number of customers and divide that by to arrive at the per customer usage. So that's what we model, the per customer usage against the weather. And as I mentioned earlier, the commercial and industrial energy usage is typically does not have a bigger impact on the weather conditions. They are usually flat profile. So the best practices that we use is to make sure that you monitor the half-hourly variance of the model. So the way that we do is we do backcast. So that means once the day is over, we input the actual weather conditions, actual pre-dispatch values and other factors and see what our forecast would be, or what we call the backcast would be, compare against the actuals. So whatever the difference that you see, that is the error that caused by the model, because other factors are all fed in as actuals. So that's an important factor that we do, and also to track that backcast over time. So if it accumulates over time, that means there's a problem in the model. So that's when we starting to look into the variables and also doing retraining as well. Important, another factor would be the external variables, particularly with the solar factor comes into play. It's very important, like in which time period of the time the solar is quite important. And in some cases, it's quite important that you capture that trough in the demand, so you have a more accurate forecast. And regular retraining of the model to adapt to changes in the customer usage behavior. So in data science perspective, we call it as concept drift. So it's very important that you detect those concept drift to capture that early. So you retrain the model frequently, so to make sure though you capture those customer behavior for the future. Another important factor when you're forecasting is that the different load profiles available, right? So these are different load profiles depending on the customer account class that we have. So for example, the New South Wales region can be divided to smart meter and basic meters. So you have smart meters that is actually recorded every 5 minutes or 30 minutes automatically, but there are basic meters, all meters that's been needs to be read like every 30 minutes, like every 3 months, and then reported back to the system. So it's important that you capture these different smart and basic meters and how the load profile changes for solar and non-solar customers as well. So in the account class here, you will see something called the business and small business enterprises. So that's not like large industrial customers I was referring to. So these ones are mostly like restaurants and small businesses. So it's important that you go into this granular level, capture these load profiles, and then do a bottom-up approach to arrive at your forecast to get a more accurate forecast. Because the load profiles, so because if you fit a one model for everything, you would not be able to capture these subtle changes or subtle load profiles that you see in different segments. So it's very important that you capture these ones separately and then you add back together to arrive at the load forecast. Because the load profiles for the solar and non-solar customers could change quite drastically, as you can see from the chart. So with respect to the models, so we do use linear and non-linear models. But the most important factor I want to mention here is it's not about the complexity of the model, it's about how you capture these relationships between the demand and the weather, right? So that's the most important part. You would have most of your machine learning and forecasting or statistical techniques at your disposal with packages and everything at the moment. But the most important part is how you capture these subtle variations, right? So you need to make sure your model able to capture linear and non-linear relationship. For machine learning techniques, obviously, you can capture the non-linear relationship automatically. But for the linear models, you need to make sure you provide the variables in polynomial terms, so you can capture those nonlinearity between the demand and the variables. And to capture seasonal patterns, right? So you have, for the hourly data, you have daily seasonality, you have the weekly seasonality, and for the countries like Australia, you even have yearly seasonality as well, because you have 4 seasons. So it's important that you capture these seasonal components in your model. And obviously the trend, the short-term and long-term trends that you will see in the model. So in Australia, in here, there's a high tendency that people are now shifting from gas-related products to electricity-related products. For example, for the heating, instead of using gas, they use electricity. So it's important you capture these trends quickly to effectively model in your electricity demand forecasting model. So it's another term what we call electrification. So that's an important factor that you need to consider. The other thing would be using a one single model would not cater for everything. So one thing that we usually do is we do model weighting depending on the period or the season or different segment. We have different models that's running, because for certain conditions, some models are better. So that's what we call the model ensembling. So you can optimize the strengths of one model or different models to improve the forecast accuracy. The other factor would be feature engineering. That's the most important thing for modeling aspects. So of course you have neural networks and other complex techniques that you can feed every feature and expect the model to be accurate. But I would rather recommend to carefully engineer your features and making sure that you can explain those demand-driven factors as well. For example, if there's a sudden swing in the demand, you need to make sure that you can explain that to the stakeholder. One of the challenges that you have with neural networks or black box model is the explainability. Of course, there are frameworks to deal with that, but still it's actually still at the growth stage. So it's important that you choose your model wisely, which has a balance between the accuracy and also the interpretability as well. So with respect to model monitoring, that's the other important thing about the data veracity. So in Australia, it's something we see very often, because the actual demand that I showed to you previously as the blue line. So there are like different revisions coming from the energy provider about that actual line. So for example, once the day is over, there will be a preliminary data that's flowing in, but after 1 month, there will be another revision coming up. That's mostly because of this basic beta phenomena. So it's important that you don't react to the actuals pretty quickly. You need to understand the data veracity as well, whether this data points is would be revised in after 4 days or not, right? So to avoid those circumstances, what we usually do is we do model weighting. So we give a more higher weight for the observations that are actually revised fully, but give a lesser weight for the ones that are we recently see. So it's important that you continuously monitor the data veracity or the how good the quality is of the actual data that you see. Otherwise, you will react into something which actually revised in after 3 months that in a different manner. So it's important that you develop dashboards to monitor such fluctuations and also to monitor whether this data is actually the certainty about the data. All right, so with respect to solar generation, so as I mentioned, in the short term, it's mostly what we get is from AEMO. So the AEMO uses satellite data to find out the cloud cover over the day. And for different parts of Australia, they would have different solar irradiance forecasting depending on the area. Obviously, because of the cloud factor, that solar generation would change quite continuously throughout the day, right? So there would be, if there's a high, big cloud cover that coming in for a particular area, the generation would go down there. And obviously that would increase the load as well. So people are importing from the grid, right? So that's why it's quite important to generate the solar forecast in the current, particularly in the energy market, right? So is it only the solar irradiance actually causing the solar generation? That's an important thing to answer. So another thing that we observed recently is that the growth of the solar profile or the solar generation profile, it's not only the weather is impacted, but it's also the capacity of the solar, right? So people are now tend to use more big solar systems, so that can generate more power, right? So over the time, so this chart, what it shows is on the right hand side, from the colors, it shows the global solar exposure. So that's a variable that basically indicates how good the cloud cover is on a particular day. So if the cloud cover is quite low, for example, the one that you see in the purple color, so in that situation, you can't see much of a trend that's happening. But in the orange color, you see over the line that actually exponentially growing, right? So if the conditions are really good, it's not only having a high profile, but it's actually growing over the time as well. So it's important that you consider that as an important factor in your forecasting, because the solar capacity is also increasing exponentially nowadays. So for given a good condition of cloud coverage or lesser cloud coverage, you will have more solar compared to past years. So that's another important factor that you need to consider. So obviously the other thing would be the geographical element into solar generation. So in some part of your country or some part of the state has a higher capacity or have a higher potential of generating the solar. So on the left hand side on the image, what you see is the potential. So it's more hot areas in Australia, so it has a better potential of generating solar. So if you are going to put a solar farm or something like that, so the red areas are the ones that you need to push. But there are other limitations as well. Obviously, you need to transport that energy as well from the middle of the country. You can't just transport thousands of kilometers. That would be costly. So it's about balancing these factors as well when you're making those decisions on putting the solar generation plants. On the right hand side, what you see is the solar capacity, like the PV capacity by postcode. So depending on like the area of the capacity, people who have installed more higher power solar panels would have more generation power. So it's not only the cloud cover or better conditions anymore, but these are the other factors that you need to consider when you are forecasting or when you are demand forecasting for solar energy, which would be a key variable for your electricity demand as well. Okay, so now let's go to these two different or extreme situations that you usually see in the energy market: the max operational demand and the minimal operational demand, right? So let's go to a max operational demand. So what are the key variables for the maximum demand days, right? So usually it's high maximum temperature. That's one of the key variables. I heard that's the issue, or not the issue, a situation in Sri Lanka these days, quite hot. So it's basically a key variable for the maximum demand days. And high average temperature at night. So that's the usual, the second peak that when happening. So if you have for example, from 4:30 to 8:30 on average, there's a high temperature. So that's a recipe for a high maximum demand day. High humidity and also the maximum temperature lag as well. So if you have consecutive maximum temperature days, quite hot days, on the fourth, say that you had 3 past days, when it comes to the fourth day, there will be higher chance that you have higher demand because that is moving forward. There's a higher temperature even at night. people would be turning on the air cons, and that would probably surge it to higher demand. So it's important that's not only the temperature on the particular day, but also a moving average that we need to consider when we are forecasting the max demand. And it also like often occurs in the working days, which when the demand is quite high. Usually in non-working days, you don't see maximum demand days. But of course, like if the temperature and other variables are blending in, there's a high chance that's going to happen in weekend, but the usual value or magnitude is quite high in the weekdays. Okay, does solar PV matter on max demand days? So that's a very interesting question. So the reason why I'm saying it's interesting is somebody can say that, okay, the max demand usually happens at, say, at 8 p.m. or 8:30 p.m. Solar does not have an impact at that time because there's no sun at that time, right? But what you need to keep in mind is like what would have happened if we did not have solar, right? So what this chart shows on the left-hand side on the weekday, so the purple color line, what you see is the max demand day profile in year 2008. And the dark green one is a max profile day that's happened in 2nd of February this month, 2025 in Victoria, right? But the light green line on the left-hand side, what you see is what if the solar has not been there, right? So that's basically adding the solar generation into the green line, right? So the key distinction you will see between that light green line and the dark green line is that the light green line is actually having a higher value than the maximum demand value compared to the dark green line, right? So obviously there has been an impact on maximum demand to reduce that maximum demand because of the prevalence of the solar. Because at that time, around at 5 or 5:30, they are still solar generating, and that's why that if we add that solar generation into the system, that the maximum or the load has reduced. So it does have an impact towards the maximum demand. The other thing is the shift of the maximum demand, right? So obviously, as I mentioned, at 5:30 previously, it would have happened at that time, but now we have the solar at that time, and that has shifted to make it around 8 or 8:30 at night. So it does have an impact, even though we think the impact is a bit minimal, but it does have an impact towards the maximum demand as well. So which is a very interesting point. So usually what we think is solar is only reacting on the minimal system demand load, but it does have an impact on the maximum demand load, given it's the shift of that shape, and also the magnitude has reduced a bit because of that change. Okay, so what are the procedures that are available in the Australian energy market to plan for these maximum demand days, right? So they have what we call the procedure called lack of reserves, or LOR, supply notices. So depending on the severity of the shortage of the supply, they categorize into 3 parts. So what I'm saying is like, so if the maximum demand is quite high, and if you can't if you don't have the sufficient demand or the sort of the generation to fulfill that load, and these are the notices that they send out appropriately, right? So basically in this instance, what happens is there's a supply demand imbalance due to the high demand, and AUMO gives directions in different time intervals. So for example, in 5 days before, they will start with the green notice, from yellow notice, saying that, okay, there is a insufficient demand levels that's starting to come in. So make sure the generators are full turn on, and there will be available generators for the market participants. So they are asking the market participants to make sure that the generators are in place at that time, right? And if you don't have on that day, before 2 to 3 days earlier, they're going to probably indicate there will be a LOR3 situation. That means there will be a chance to load shredding. That means there will be blackouts, right? So the objective is to make sure you get ready in advance for these situations. So you forecast the maximum demand and try to find out to find out the balance for the generation. And if there is the imbalance between the demand and the supply, you need to make sure that you have enough supply in the system. So the AEMO would encourage all the participants to make sure you are running all the generators as to the fullest, right? So it's not only the maximum demand days, these LOR will be issued. I mean, in situation like, for example, there would be an unplanned event that's certainly happening for the generation, like a big generator trips off, then there will be a LOR notices as well. But that is quite unpredicted, but that could happen as well. So in that case, yeah, we'll be probably going for the LOR 2 and 3 directly, not like a maximum demand driven day. But there are some other preventive measures, like the reactive measures that not only preventive, reactive measures done by AEMO as well. For example, demand response mechanisms that they employ. For example, this is one good example that they do demand response in recently for the state of Victoria. So one of the CNI customers who's Portland aluminium smelter load. So that's a big aluminium smelter in Victoria. So it on average uses like 500 megawatts, which is quite significant. So for the duration of times that are having higher demand in the States, so the AEMO or the energy retailer usually calls that customer and asks to reduce the load from 500 to 200. So any compensation can be then claimed by the government or from the energy retailer, but just to ensure that the market is not having any blackouts. So they actually reduce their demand to make sure they are actually adhering with the LOR notices. So that's one of the responses that's been recently taken by the energy operators towards the CNI customers. And there are other measures like New South Wales peak demand reduction schemes as well. So these are schemes that's been introduced by the state government to make sure that you reduce the consumption on maximum demand days by incentivizing the energy retailers by giving certificates, like energy certificates that can be sold into the market later, in case that they can reduce the maximum demand in their load profile on these 4 maximum days. So there are different incentives that's being picked up there as well to make sure to mitigate this risk of not having enough supply in the system. Okay, so moving into the minimal operational demand. So we have not seen this minimal operational demand like 8 to 10 years back, but we are seeing it now mainly due to the solar injection, right? So this is a half-hourly profile of South Australia, which is a state that uses solar a lot. And you can see how the half-hourly profile has changed over time from 2014 to 2024. The trough, how the day trough has gone very low over the years. So that is the reason that is causing the minimal demand through that period of time. So that is actually caused by the solar, right? So key variables for minimum demand days. So obviously the high volumes of rooftop solar can reduce the system demand, which obviously can pose risk to grid security because that would probably imbalance the supply and load, right? And the other key ingredients would be the mild average temperatures. So people are not using air cons and other electricity units, and obviously cloudless skies with high generation of solar, and it could be happening in a non-working day as well, right? A very similar incident that happened in Sri Lanka recently. So to balance this system frequency, low and high, you need to make sure that the system needs to be secured. So in a situation that you have higher supply into the system because of the solar, the demand or supply has to be balanced to make sure that that you hold that equilibrium between the demand and supply. So the AEMO has these notices for these minimum system loads as well. So they have, again, a yellow one and to the red one. So initially what they do is they offer like 6 to 7 days ahead. They say that, okay, in this day, there will be MSL1 event that's happening. That means a minimum load day that's going to happen. So probably asking the market participants to reduce the amount of generation that needs and only keeping the more necessary services to be run on the generation side. And also it tries to increase the electricity demand by asking the participants to charge their batteries, so that would increase the load, and also to use pump hydro to pump the water for the generation for the later purposes. So that would probably increase the demand. So it would taken from the system demand itself. But on the third line, which is MSL3 on the red, which is not really good color. So so in that sense, usually they do the solar curtailment. So if you can't address the MSL1 and 2 with the necessary events, they had to go into the MSL3. That means using emergency backstops to cut off the solar from the system. So the supply would be reduced to match with the demand. So basically, yeah, that's the last resort that they have to the to balance with the frequencies between the supply and demand. So they to reduce the generation. Oh, sorry, the so the reduce the generation that's happening with the solar. All right, so moving to the last part of the presentation on load forecasting in next into 20 years. So it's very important that you consider the factor of the growth of the DER, or what we call the distributed energy resources. So you have solar and the wind, the batteries in place. Particularly on the wind, you have the offshore wind plants, and you have the onshore wind plants that are really contributing towards your energy. So these factors are affecting the load significantly, and also into the future, if you are plugging in more EVs, that would increase your demand as well. So we are mostly talking about the factors that could drop down the demand, right? Like the solar and the batteries, but there are factors that could increase the demand as well in the future, like electricity, like the EVs in the vehicles. And people are electrifying as well nowadays, particularly in this part of the world, try to shift from gas to electric system. That would also increase demand. So it's not only about decreasing the load because of solar, but there's another part that's coming out. People are more electrifying. That would increase the load aspect as well, which is a interesting fact. And there are smart appliances as well that people usually change the way that they charge or the way that they use their appliances depending on the time of usage. And the other factors would be the climate change with extreme weather events. There can be intensive hot heat wave storms, and that could also to lead to minimum demand conditions as well. So it's important that you predict these maximum demand days and the minimum days in advance, so you can react to those in advance to have a minimal impact towards the household. So we don't go into that red line of a cutting of the solar or losing energy, leading to blackouts in the market. And other thing would be the seasonal shifts. We have seen that recently, and here in this part of the world, we have seen warmer winters as well. So even though we predict high gas demand, we actually see warmer winters, and that actually causes to go down a bit. So that's again apart from climate change. And other factor would be the influence of economic factors. So if there are cost of living pressure, people tend to use less energy there, right? Turning off the heaters, turning off the air cons, just to make sure they have the lesser cost of energy. So that also another factor that's influencing towards the load forecasting. So there's myriad of things that could affect towards the load forecasting, and obviously that brings challenges, and that would be an interesting topic and interesting areas that to be invested in the next couple of years. Yeah, so that concludes my presentation. Yeah, happy to get any questions from you guys.
Dr. Konaren,
Yes.
are you there?
Thank you very much, Dr. Kasum, for your very insightful and very informative presentation. Actually, it was very interesting when your presentation is progressed. It is really inviting. Okay, so your presentation is very important, especially our national thematic perspectives, and also when we consider the stability of our grid In all these aspects, your presentation is very important. And I would like to extend our heartfelt gratitude on behalf of IESL to you for accepting our invitation and make this presentation today. Okay. So now I would like to open the floor for the questions. And I would like to have some interactive session from now on. Therefore, first I would like to go for physical questions. Okay. Please, participants, can you raise your hand, and then I guess you can present your questions to the presenter, and Dr. Kasun can answer your questions. Yes, please. Engineer Shahara.
Yes, I have adjusted the settings so they
Okay.
can unmute themselves.
Okay.
So they should be able to unmute.
Yeah,
Okay.
Dr. Konar, can you hear me?
Yes, please go ahead.
Yeah. Thank you, Mr. Kasun, for the insightful presentation. That actually I have two questions. First one, I already sent to the chat box that as you said that there was some sudden demand variation due to rejection of some kind of a large customer load around 300 megawatt.
Yes.
Normally, the utility will forecast the large customer their load requirement, or do the large customer should provide that their load requirement or day ahead, or maybe some forecast pattern? That's my first question. The second question is that the rate of energy, the bidding rate of the rate of energy in the graph you presented, that I have noted that in the evening time there is a rise and sudden drop.
Yeah.
Are there any particular reasons? That's my question number 2.
Yeah. Good questions. Yeah. So the first question is that so usually the retailer provide the forecast for the big customers, but the big customers do usually give the retailer about their half-hourly profile. So based on that, we do the forecast for the large customers. But these interventions, like the demand response that I was explaining about, that usually happens on the day. So the AEMO or the energy retailer asks the CNI customer, okay, based on your previous, like the past data, this is the forecast that you have. So on average, you will be using 500 megawatts on the day, but can you please reduce it to 200? Because there would be a situation that we will be shortfall of some energy. So we would like to, ask you to reduce the amount of demand that you are using at that particular period of time. So now you would probably ask, okay, that would be a like costly approach for the customer, or that would be a loss for the customer. But usually that is compensated by the retailer or the energy market for that period of time, because that basically helps to save the stability of the grid. So that's the usual process. The forecast does not like provided by the CNI customer. It's usually provided by the energy retailer attached to that customer. But to get those forecasts, usually they give past data. So that's how we provide the forecast to the system. Hopefully that answers your question.
Yes. Thank you.
This one. Yeah. And the second one that you have, this chart, I guess. So the reason that you have the price peak, so for example, usually once for the second peak, they usually run gas generators. So the gas generators are relatively expensive compared to the coal ones. So once you to rev up a gas generator, that prices peaks up. That's what you see the peak on, like for the second peak that you see in the evening. And then they don't like, for the bidding activity, they don't put like more expensive prices, because otherwise they would be probably rejected by AEMO if they're going to keep putting the prices up. So that's why once it's revved up, to keep it more profitable, they push the price down. So that's why these spot market prices coming to down as well. So it's not like every time if the demand is high, you can keep putting the prices pressure. So once the prices are high, once they turn on, you can't just turn off the generator because that would be a costly thing for you. And that's why, to make it more competitive on the price, once it started the generator, it tries to put down, say, from 500, say from 400 to 200, just to make sure that you are running that gas generator for prolonged period of time. And that's why you have that peak and then sudden drop there. Otherwise, that would probably have a stabilization until that peak is gone. Is that clear?
Yeah, that makes sense. Thank you. Thank you.
Okay, thank you. Yep.
Okay, thank you. Engineer Ajit, you can go with your questions, please.
Thank you so much for the opportunity. Thank you so much, Dr. Kasun, for the insightful presentation. Rather than a question, I have a clarification. Now, I
Yes.
saw in one slide, depending on the amount that we supply for the grid, the price is determined, like
Yes.
online would like. Can you just clarify that this particular slide, please? Yeah.
This slide, yes. So the way that happens is, so the AEMO provides the generates the demand forecast every 5 minutes, right? So that's what we call the settlement. So say that in the next 5 minutes, the demand is 350 megawatts, right? So to fulfill that 350 megawatts, you need generators, right? So it asks the generators to bid for a particular bid based on the prices of the cost of generation, right? So on the y-axis, what you see is the short-run average cost in megawatt hours, right? So there will be generator A bidding, 50 megawatts at $5 at megawatt hour, right? There will be another generator B, providing another 50 megawatts at a different price, right? And once they stack up, you can come into the 350 megawatts of the demand that you need to fulfill in the next 5 minutes. And that's how they determine the price. So whatever the price that's meeting with the 350 megawatts, for example, in this scenario, it would be around $22. So that would be the settling price. That would be, the market would be settled at the next 5 minutes. So for example, say that's 11:30 here. So at 11:35, that would be the price that the market would be settling. Then you have 11:40 that comes in, say it's a 500 megawatt is the demand that you are given by the AEMO. Then you need more generators to bid in because you need more capacity to fulfill the 500 megawatts. And then you stack it up and say the market clearing price would be around $30 because that's the price that the market would be clearance to meet the 500 megawatts, right? And that's how this bidding process actually works in the physical markets on the Australian energy market side. And the prices, as I mentioned, that could go into volatility from -1,000 to 17,500. So now what you would have, the question is like, do we as a retailer, do we have to bear that risk, right? So the prices are fluctuating so much, right? Would that be, we are the people who are absorbing the price because you can't charge the customer $17,500 of megawatt hours if they are used for like 10 minutes, right? That's a huge cost for them. So there's another market which I've not touched upon, that's on the medium term forecast. There's a financial market that actually runs alongside with this bidding model. So the generators and retailers can buy the insurance to make sure the prices are set on the fixed price. So generators would like to get a more higher price, but the retailers would like to go at a lower price. That's how it usually works, right? So that's, you have a different market for that. That's what we call a forward market. So this is a physical market. The medium-term forecasting itself a different scenario, which I've not touched base because of the time limitations I have. But yeah, so that's on that bidding market that we have. Hope that clears your question.
Just one more clarification, Dr. Kasun. Now,
yes,
with regard to this 350 megawatt, the capacity, the price factor $22. How does
Yes.
it come? Is it from your government side it comes, or it is a
No. So each generator has to provide a cost for that capacity every time, right? So so for $5, and the other generator comes with 400 megawatts with this price, and yes, the settlement price, which is the $22, that is determined by the AMO, but that price is actually determined by the prices that's been bid by the participants in the system. So it's not like $22 is determined by the Australian energy market operator itself, but the price is constructed from the biddings that's been pushed by the other generators in the system. Is that
One
clear?
last point, Dr. Kasun.
Yeah.
Is there any competition for the bidding? Now we have a limited requirement. If more and more suppliers want to bid,
Yes.
is there any kind of a control on that?
Yes. So AEMO has some restrictions on like the generators and retailers. If you want to become a participant, there are financial and other constraints that they have put place. But at least to my understanding, there's no like something like any limitation as per se. More bidding, that means there would be a more better competitive prices. That's what the government wants, to get a better competitive prices to the end user, right? So more competition means that would end up with a better price for the people. So that's why they don't want to act as a monopoly. So there are multiple generators and participants in the market.
Thank you so much, Dr. Kasun. Thank you so much.
No worries. Thank you. No worries.
Okay, thank you very much, Engineer Ajit. I believe you are from Ceylon Electricity Board, representing the renewable energy branch, and thank you very much for your very focused attention this national thematic requirement.
You are welcome, sir. Thank you so much.
And do we have more questions? Please, I kindly request you to raise your hand, and then we can go. Yes. Engineer Dileep, do you have a question?
Yes, if I may take the chance.
Yes.
First of all, thank you, Dr. Kasun, for the informative presentation. There are a couple of questions I have regarding your presentation.
Yep.
First of all, regarding the tariff category, I was listening to it. I was curious as to whether you have voltage-based tariff simply, or is there tariff category, and if there's a significant variation, like do you do the demand forecasting and sensitivity analysis for each segment, because there would be a significant variance in that case. And the other thing is, like for retailers, do they have an incentive provided in the system to increase their load forecasting, like by investing in probabilistic load forecasting, and to invest in their capabilities rather than doing the traditional thing? Because if the risk is in the second kind of balancing market, if that risk is
yes,
well, I like that aspect. Thank you.
Yes. Yeah. So the first question around different tariffs and why it's important to produce different forecast profiles and to have different models to produce more accurate forecast for different profiles. Yes. So these load profiles are a key variable to the input for pricing these customers. So that would be mass market customers and CNI customers. So to price these customers, you need accurate demand forecast. So for example, the retail load for mass market and another CNI customer with a different profile would be quite different. So the tariff side that you are mentioning, that would be different for these different segments. So that's why it is essential that we capture these different segments. For example, for the solar customers and non-solar customers, that would be priced differently, right? So that's why we need that forecast in differentiating manner. And what for the second question? Sorry. That's about the incentive on the load forecast, right? Yeah. So
yes,
that's on. Yeah. So for the retailer perspective, it's a benefit for the retailer. So if you forecast your load properly, right, you can understand like which part of like, for example, say that your actual like the the load is 1000 megawatts, right? But you have a generation of only 800, right? But you need to find out the other 200 if that is the case, right? So where that 200 would be fulfilled, right? So that's why you have this, what we call the forward market. So we look into from other generators, can we purchase another megawatt 200 to capture, to fulfill that demand, right? But if it is a long position, that means if you have more generation in your portfolio than the load, you can actually sell into the market because you have excess energy, right? Say the price is like around 17,000 on the day, right? For 1 hour, right? And your generators are running as expected, right? And you have covered your load and you have like excess generation, like say 100 megawatts that's running on that price, you will be earning a lot of money, right? So that's the incentive for the retailer to earn more money. But from the AEMO side, from the government side is also, they are usually encouraging the retailers to produce more accurate forecast, which will be reflected in their bidding stack as well. So, but the most benefit is actually for the retailer to make sure that you generate the demand forecast so you can flex how much you can sell and how much you need to buy depending on the load that you have. Is that clear? Is that clear?
Yeah, so in other words, it is
Yeah.
typical there for generators to also be retailers and or to own portfolio as well, right? That's a typical arrangement.
Yes, yes, exactly.
Understood.
So I mean, so there are people who only use retailers as well. So there are like, so they will only bill the customers and you have a margin and you earn the money as a retailer there, right? But there are gentailers, just like in Energy Australia, for example, AGL, Origin, those are gentailers. So you have a generator as a business as well as a retailer as well. So both the sides. So yeah.
So in that case, I assume there are regulatory requirements for ring fencing the accounts between generation.
Exactly.
Okay.
Yes.
Understood. Thank you very much.
No worries. Yep.
Okay, we have Engineer Navodana Kankadamge. Yes, please go ahead with your question.
Thank you, Doctor. I have a small question. Do you have something like sudden power injection at a fault, like battery energy storage systems or STATCOMs? If then, how is there also coming like this kind of bidding process or another method? That is first question. The second one is, now, as you said, the medium bidding process is going, I think, as I understood, for the energy. This is spot market is coming for the intermittency and power injection, right?
Yes. So the yes, agree. Yeah. So it's the physical market is also basically for like on the day, how much demand is there and to have the generation. So basically operative wise to make sure it's running. So the lights are on in households, right? On the forward market is mostly for covering. You make sure that you are financially intact, that you can cover your load. So if you have excess energy, you can sell, or if you don't have the excess energy, say for the next year, you just need to buy from somewhere else, right?
Then other thing is,
yeah.
loads are connected to your grid in different locations. So while you are taking next generation as a spot market, are there any constraint we need a generation to this bus bar, or any constraints are there, or otherwise to the national grid, anywhere you are taking that power?
Yeah. So the first question, that you have like a sudden surge of energy, or whether we have a different mechanism. So that, yes, we do have something called this FCAS market. So it's a frequency control ancillary services. So it can suddenly increase the injection of electricity, so the energy, or push down the energy. So it has a different bidding framework for that. So along with the normal physical market bidding framework that you have, which I have discussed, there's another separate market for this one, for the FCAS system. So in case of a sudden surge of demand, how these demand would be allocated. So usually the prices are a bit high there because those are like served for more specific purposes. With respect to the constraints on the grid, at least to my understanding, yes, we don't have such a constraints on the network side aspect on like how many bidders or generators that can be involved. But the key part would be like I mentioned about the geolocation of the generators as well. For example, in some cases, there are like the generators or the energy will be transferred across the states as well. But when you're transferring the energy across the state, there are constraints as well. For example, there would be only 200 megawatts that can be transferred between Victoria and New South Wales in a situation that the Victoria doesn't have any energy in that case, right? So you don't have any constraint per the geolocation of the generator, but of course, due to the limitations of the transmission lines and the distribution line, it does have a constraint of how much energy that can be flown and the other generation limitations, but it doesn't have any limitations on the bidding structure though. Hope that answered your question, 2 questions.
Yes, yes. Thank you so much for your insightful presentation, and thank you very much, organizers as well. Thank you.
Yeah, thank you very much, Engineer Navodana. I believe as a person who managed several national renewable energy projects in Sri Lanka under CEB, you may have so many clarifications. I believe Dr. Kasun has adequately clarified your concerns, isn't it?
Yes, thank you so much.
Okay, good. I don't see raised hands, and I have 2 questions to Dr. Kasun. Okay.
Yep.
My first question is, when we come to a European energy market, we can see day-ahead the basic structure. We can see day-ahead market and the intraday market and the balancing market, which are operating in a series manner. When we come to Australian energy market, do we have the same structure, or can you please explain the basic structure of the Australian energy market?
So they do have like usually not only day ahead forecast, but they do have like 14 days ahead forecast, that is the daily forecast. And they do have a half hourly the shape forecast as well. So it's not only aggregated daily value, it will be a half hourly forecast profile that you would have every 5 minutes. So because the 5-minute bidding strategy needs to be accomplished by the 5-minute demand as well. So that's why they would have 5-minute demand time series for the next 14 days. So usually they have what we call pre-dispatch demand forecast. So that's what we call the pre-dispatch. So that's what the energy market assumes to be the demand. That's the pre-dispatch one, which also captures the behind the meter changes and interventions there. But once the day is done, they actually convert that into what we call a system demand. So the pre-dispatch demand becomes a system demand once we have the actual demand data. Yeah, so it's a bit different to the European energy market. But yeah, so the frequency of the demand or the frequency of the forecast that is available in the system is that 14 days ahead forecast and the half hourly profile that you have. But the most important part would be then the energy bidding strategy that we have to choose which generators to be run on each 5 minutes. So we need to submit as generators, you need to submit your whatever the demand and the prices 1 day ahead, but you can change the prices like for a T minus like whatever the hours before you can't change after your bid after some hours has been passed, right? Because that would basically have a instability of the grid. For example, like in the middle, you can't just say that, okay, I can't just generate these 200 megawatts, I'm getting off, right? So that would have like serious consequences for that generator. So that's how that, like the framework that has been developed from the Australian energy market perspective.
Okay, thank you. Is there any role of this energy market in managing contingencies?
Yes,
During a
so in
contingency,
the
is there any role of this energy market? As far as I understood from your explanations, that's what I get. Yes, is there any role?
So the AEMO is the energy market regulator, right? So in situations like, say that the prices has gone to 17,500 on the max demand days, and if it does go for like 2 to 3 hours consecutively, right? So the AEMO has the power to shut the bidding market, and they would propose a price. So that all the generators has to have to generate the prices, generate the energy to according to that prices, right? So in terms of a contingency, that's they have the fully role or capability of intervening the market, setting the prices, as well as giving the notices on LOR with respect to the lack of reserve notices, uh, with respect to the contingencies that you will see in the minimum system load as well in the MSL perspective. So AEMO has those responsibility, and also they have the correct directions to navigate in such contingencies. That's why I mentioned they have these in advance, they do the forecast, and as a contingency plan, they have put these different tiers. So depending on the severity of the tiers, they take the market participants and ask the participants to turn on and off the generators, and that's how they usually regulate the market.
Yeah, okay. Thank you very much, Dr.
Answer your question? Yeah.
Yes.
Okay.
Okay. Shall we go for some questions raised at the chat box? Engineer Sahara, are you there?
Yes, I'm here.
Yes, I just request from you.
Okay.
Can you please pick
Read
some
out. Yes.
good questions for our discussions? Yes, please.
So actually, there's one question that was asked like a few minutes ago. Are the rooftop solar producers, small scale producers in kilowatt range, I think they're talking about with regards to Sri Lanka, in Australia, engaged in some sort of time of the day tariff or similar kind of tariff for their energy export to the grid? Do they want to bid as well? So that is one question.
Yeah. Okay. So usually the rooftop solar participants, they can't bid to the market. So if there's like a huge solar panel with a solar farm, yes, they can be a participant in the market with for example, the battery, right? So you can be a participant, but the normal households, they can't be usually because, as I mentioned, to become a participant, there are so many financial regulations that you have to go through, and there are so much thresholds that's been put by AEMO to minimize, to avoid any bad influence, like the bad participants in the market, right? So usually they can't bid to the market. But with respect to the tariff, yes, they do have time of the day tariffs in the solar, but usually, at least to my understanding, they are mostly given for the battery customers who are actually having solar. That's usually the time of the day tariff. Otherwise, the tariff is quite flat, and also the tariff is really low, to be honest, in Australia. So it's mostly the solar installing is not to get revenue from exporting to the system. It's mostly self-consumption, to be honest. So if you put into the exports, you will get a very lower tariff at the moment. But it's a self-consumption that the people are looking at on the day with respect to the solar. It's not mostly you are getting so much money from exporting to the grid. It's mostly around self-consumption on the solar, at least in the Australian market.
Thank you very much, Dr. Kasim. So there's one more question. I think it's more of like you might have to clarify some things, because I think this question was quite answered. But again, does the market cap determine the price for all generators participating in the spot market, or do they receive payments based on their individual bidding prices?
Yeah, so the price is actually determined by the total, to the highest price that's been able to meet with the demand. So that will be the settling price. But the market price cap is the maximum price that would eventuate in the market. So for example, say that some generator has bid in $100, and then to eventuate that demand, say for 900, the price has gone into 17,500. So the generator who has bid to the 17,500 would give 17,500, and also the generator who has bid on $100 would also get 17,500 for 1 megawatt hour. So that's how the market settles there. But the market price cap and the -1,000 I was referring to, both these prices are set by the energy regulator, Australian Energy Market Regulator, and they revise that each yearly.
Thank you very much, Dr. Kasun. And I think Dr. Charit also has answered some questions on the chat as well. So there is two questions actually from the same person, but I'm also not quite clear about them, but I would wish if they can unmute and ask. The first question was, is electric car extended smart energy? And the second one was, I think, rather a comment, like demand curve may contradicting. So I think it's not really clear regarding these two questions.
I think maybe what he's asking is like the impact towards the load profile because of the batteries and the EVs, I think. So it does have an impact on the shape of the load. Obviously, for example, batteries on the day you would charge and then you will be discharged at night, right? So definitely there would be an impact towards the profile of the energy profile, half-hourly profile of the average customers. But one thing that I noticed, at least in here in Australia, the batteries is still not up to the, I would say, the standard that we see in the solar. Even the cost of the batteries, like at least the household batteries, the cost is one thing, and the other one is the longevity of the batteries. So it's still not up to the extent that we have developed the solar. The solars are so much evolved compared to the batteries. So that's one of the reasons you would see not much of an impact from the batteries. But if you look into those specific customers with the batteries, you do see that shape. So people basically discharging their battery at night, right? When there is no solar. EV would have an impact because that would increase the load. That would we basically have to charge our cars, EVs there. So that would definitely increase the load of the demand. And how that gets the demand, I mean, the supply, maybe it's directly fed from the solar generation. So that would be, you can charge your car. But in some instances, if you are charging your car overnight, right, then obviously you need to use the grid. That would probably increase your grid demand at night as well, which not usually see typically in the market. So that would definitely, those two factors would definitely impact the load profile.
Yes, thank you, Dr. Kasun. I think it answered their question. So those are the only questions that I can see over the chat. So, yeah,
Yes,
we have answered
thank you.
everything. Thank you.
Yes.
Thank you.
I think Dr. Kasun has answered all the questions, almost all the questions adequately. Okay. Now I think we have come to the end. So I'd like to invite our chairman of the Electrical, Electronic and Telecommunication Engineering Sectional Committee to give the vote of thanks.
Yes, it has been a wonderful presentation listening to Dr. Kasun today. And I personally have learned a lot, and I believe everyone who was in the audience, nearly 75 participants maximum at one time. And most people have left now after their questions got answered, I assume. But we had a very fruitful session, very insightful, and a lot of information regarding how the Australian energy market is operated, particularly when they come to forecasting. And Dr. Kasun has explained that the different scenarios, the maximum demand scenario, the minimum demand scenario, which we encountered very recently and which led out to a very different situation in our country. So I think we are still way back, like very behind Australia, but I think we are trying our best to catch up with incorporating these newest technologies. And it's time, I think high time for us to think about inventions or new innovations, new ways of thinking to address the issues or problems that we have in our country. But this insightful presentation gave us a lot of thoughts, a lot of things, avenues to think about, critically think about, and also a lot of knowledge, even it was a very short time. So I would like to take this opportunity to thank Dr. Kazun for his time he has spent, and he has put all this information in a very systematic, structured way. So it's very easy for us to go through and understand. And thank you very much, Dr. Kasun. I think it's very difficult to put in so much knowledge into a 1 hour presentation, but I think you have taken most of the cream of the concepts and shared it with us today. So thank you very much for this opportunity you gave to us to learn from you. And now I would like to
Thank you very much.
Now I would
Thank you
also
very
like to take this opportunity for the person who brought you here today virtually. I think it's Dr. Charit Jayasekar if he's there in the forum. I would like to take this opportunity to thank you a lot, Dr. Charit, because he's the person who invited Dr. Kasun and got this date and this time from Dr. Kasun and put a lot of effort to organize this. Thank you very much, Dr. Charit. Because of you, we were able to get a personality like Dr. Kasun today for our sectional committee webinar, and we got the opportunity to learn from him. And all of us who participated got answers to a lot of burning questions. And last but not least, I would like to take this opportunity to thank Dr. Konar. He is the chair of the subcommittee who is in charge of organizing public lectures and webinars and seminars of the Electrical, Electronics and Telecommunication Sectional Committee this session. So he's been a great support, a great resource for me. So I have complete trust in him that this session, now we have conducted 2 webinars, including this one and the upcoming webinars as well. I believe in him that there will be so many different topics that are very useful for us as engineers, not only electrical engineers, electronic engineers, but also even for general public. So this opportunity, this thank you goes to you, Dr. Kasun. And also I think I have to thank our wonderful audience for joining with us. There's been a good number of participation and also very interesting questions through which again we got the opportunity to learn. And also I thank everyone who is behind this, the IESL IT department and everyone who is supporting us in conducting these fruitful sessions. So with that, I think we can conclude this webinar, and we look forward to meet you again in another interesting webinar with another interesting topic and a resource person. So thank you very much and have a great evening.
Thank you very much. Thanks again for IESL and everyone for giving me the opportunity, and I hope you had a insightful session and happy to share more information in the future.
Definitely, yes. We will keep in
Definitely,
touch.
Dr. Kasun, actually, myself and Engineer Sahara, we were discussing and we were thought of reaching you to as a requesting to be a resource person for a upcoming CPD course. Okay, we will discuss later on that one. Okay, so I request you to please keep touch with us.
Yeah, sure. No worries.
Thank you very much.
Take care. Have a good evening.
Thank you very much.
Yeah, good evening to you all.
Good evening.